Okay, I'm going to get you started on 8.5. I had some students that were having trouble getting started on this, so I'm going to show you how to work these problems. I've already worked this one, but I'm going to go through the steps again. First of all, always view an example to get the formula, just to show you what the formula means. First of all, you have your z value. You're going to take whatever your alpha is and divide that by 2. So the way we figure out what that value is we take the number 1 and we subtract our confidence interval. So if our confidence interval is 0.99, 1 minus 0.99 would be 0.01, and we want to divide 0.01 by 2, which would be 0.005. Now, if you look down here in this example, it's the same confidence interval. You take 1 minus the confidence interval and divide it by 2. So that's our value is 0.005. And then the next step is to basically plug in your formula, because we know what our margin of error is. That's given. And it also gives us what sigma is. Sigma is 91. Okay. So we have everything else. The only part that's not given is our z value. We're going to have to go in and we're going to have to look at the table to get our z value. So once we get our z value, we square it, and then we would square whatever our sigma is, and we would square margin of error, multiply the top, divide by the bottom, and we will get our answer. So really, you're just plugging into the formula except for your z value. That requires a little bit more work. So how do we get this z value? What you do is first of all, you're thinking you would use this and get the area here. But it's kind of confusing, but we're working backwards. So if you go, let's say our value is 0.005, okay? If you go to 0.005 on your chart, that would mean we want a 0.095. Let's see if we can find that. Sorry, I got distracted for a second. So 0.95, if you take 0.905 is what we're wanting. 0.905, because let me go back and show you real quick just to make sure that I didn't confuse you even more. When you get to this, I didn't mean to go there. When you get to your example, let me go back and show y'all. And you get 0.005, okay? If we continue here, the critical value of, you're going to use your table, okay? In the case, it falls halfway between two table values, so the two values have to be averaged. So let's just look. Now, if you have 99% confidence interval, the z value will always be 2.575. And you can just kind of make a note of that. So if you have another problem that has a 99% confidence interval, you can use 2.575. But if you will look down here, 1 minus 0.005 would give you 0.995. Well, 0.995 let's see if we can get really, really close to that. 0.9995 would be in between these two, because here's 0.9949, here's 0.9951. So it's halfway in between these two values, right? Because 0.995 would be in between. So what you're going to do is you're going to take 2.57 and 2.58 and take the average of that. 2.57 and 2.58, if you add them and divide it by 2, you would get 2.575. So that is how we get our Z value. So when you plug in, this is all you're going to do. Your Z value is going to be 2.575, square it, times your sigma, which is in our problem is 73. So 2.575 squared times 73 squared. You're going to multiply those two numbers together, and then you divide by your margin of error, which is 15. If you square 15, you would get 225. So up here, if you square 2.575, you square it, you get about 6.63. If you square your 73, you would get 5329. Divide that by 225. So it's three values that you're using for this formula. The Z value is the one that you have to come up with based on your confidence interval. The other two values are given to you. So once you divide, use your formula, you're always going to round up to the nearest integer. Okay? So what is this giving me? My answer is giving me the sample size I need to be 99% confident that the mean is around a particular number with a margin of error equal to 15. So the more confident you are in your sample, the bigger the sample needs to be. So if I only picked a sample of 2, I'm not going to have as much confidence as if I pick a sample of 100, because 100 is closer to the population than just picking 2 samples. All right, let's look at another one. Problem number 2, you work it the same way, except our confidence interval is 90%. So 1 minus 0.90 would be 0.10 or 10 cents if you want to think of it that way. So 0.10 divided by 2 would be 0.05. So if we look at our chart here, 0.05, 1 minus 0.05 would be 0.95. So 0.95 would be halfway in between these two values, 1.64 and 1.65. So if let me make sure that that's right, 0.90, yes. So 1.64 and 1.65, see, there's 1.6, go up 1.64, and then here's 1.65. Add those, divide by 2. So your Z value associated with a 90% confidence interval is going to be 1.645. That's the number that we need to get to. And I believe, let's see, they use 99% on the example. So we're going to use 1.645. So now we have our Z score. So 1.645 would go here, and we would square it, and we would get 2.70 something. Then we're going to square sigma. Our sigma value here is 24, so square 24, and you get 576. So 2.7 something times 576 on the top. Your margin of error is 5, square it, and you get 25. So if you take the top, what you got on the top, and divided it by 25, you will get a sample size of 62.3. Since we're rounding up to the nearest integer, 62 is going to round up to 63. I know normally rounding rules, we would leave it as 62. But you're always going to round up if it says round up to the nearest integer. Number 3 is basically you're working it the same way, but here we're going to use you have A, which is 25, B, 40, and C, 50. We're going to determine the sample size for the interval, and these are the different population means we're going to use. So you basically have 3 different problems, but you're going to work them the same way. Remember, 90% confidence interval, the Z value associated with the 90% confidence interval is 1.645. Okay. And let me make sure that that is everything you need to know. Okay. Problem number 4, very, very similar to what we've been doing. You're still going to have your Z value. Remember, 1.645. We don't have to look that up anymore. You can start kind of remembering that. But the difference is we're using proportions. So we have a different formula to use, but you're just plugging into your formula. So here, same thing we've been doing. Z value with our confidence interval is 1.645. Then you have P, okay, that's given to us. So plug in 0.45 where P is, and then 1 minus 0.45 here. So where you see a P, you're going to plug in 0.45. So we have 1.645 squared times 0.45 times 1 minus 0.45, which would be 0.55. So these two numbers, you don't really have to know this, but you're going to get 0.45 here and 0.55 here. They should always add up to 1. So that's one way to figure out what number goes where. But again, you're just multiplying 1.645 squared times 0.45 times 0.55. This is coming from the given. All you're doing is plugging in. You're plugging into a formula. On the bottom, we want the margin of error, and it is 0.08. You definitely want to make sure you put 0.08 and square it. Okay? Once you multiply up here and then divide by the bottom, you will get 104.64 rounded up to 105. And that's pretty much it. I think for most students, it's the formulas that are hard to read. But once you figure out that most of this information is given, I think the hardest part is getting used to figuring out the Z-score. But if you have any questions, just message me. And I hope that this helps you work homework 8.5.